So we're looking at worksheet 2, orbital diagrams and quantum numbers. So you've had some practice with quantum numbers now. Today is just more practice. We're introducing one extra element, which is valence electrons. So there's two things we need to start off with. One, we have our off-ball principle, and we're going to draw the arrows through this. So on a test and quiz, you won't be given this, so you need to know how to draw this. And we talked about that last time in the last video. You also have the quantum number steps. So this is just a cheat sheet to help you out as you're trying to fill out quantum numbers. Same thing on a test, you won't get this on a quiz also, so make sure you know this. And then last thing, you have the introduction of valence electrons. So you're going to write the definition here, and that's the electrons in the S and P orbitals of the highest energy level. And I'm going to underline S, P, and highest energy, because that's what's really going to matter. So we'll look at that at last, but we're going to start with a few examples. So through each example, I'll walk you through how we fill out all these boxes, and then I'll leave you some to do on your own. So if we look at fluorine, if we look at the periodic table, its atomic number is 9. So we're going to represent those 9 electrons in an orbital diagram. So let me pull this down so we can see the top. So we're going to start with our 1s. Our 1s can only hold 2 electrons. So we're going to draw our 2 arrows, one up and one down. And so we still have 7 more electrons. So next is 2s. And we're going to occupy that completely. So our up and down arrows. Okay, after 2s, we have 2p. Because we've only drawn 4 arrows, we have 5 more left. So remember, when we're drawing a p have 3 orbitals. So we draw 3 lines. Okay. Now remember, I said we only have 5 left because we did 2 here, so that's 4. We still have 5, so we're going to write 5. And for some people, it's easier to draw the arrows and then put these exponent numbers. So in the next problem, I'll do it that way if this way is confusing. So 1, 2, 3, 4, 5, 6, 7, and 8, and 9. Okay, so those are my 5 arrows. So when you're doing this, you're looking at the last arrow you drew. Okay, so we're looking at the last arrow here, which is this arrow. And for our quantum numbers, right, let's write our 4 quantum numbers. So first is the energy level, which is 2. Next we're in a P, so P is 1. The location that it's in within the P, it's in the middle orbital. So for P, the middle orbital gets 0 value. It's a down arrow, so that's a -1/2. Now if we go to valence electrons are the electrons in the S and P of your highest energy level. So we're looking at this, our highest energy level is 2. And we're looking at the S and the P. Okay, so the total number of electrons is 1, 2, 3, 4, 5, 6, 7 electrons in the highest energy level of your S and P. Okay, so valence electrons are the electrons in the outermost shell, but this is how we count them. Now let's do 2 more examples together, and then you're on your own. So let's look at calcium and iron. So calcium has an atomic number of 20. Okay, so we're going to start with our 1s. Okay, this time I'm going to draw the arrows first before I put the exponents. So here's 2 arrows, 1s2. Next is our 2s. Right, I'm just going through this chart up here, so I'll put it to the side. And that's going to use 2 arrows, so 2s2. After 2s is 2p. 1, 2, 3, because it's a 2p. And I'm drawing in my arrows. And so I see that I used all 6. I had to, because we're still not at 20 yet. So we're only at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So after 2p comes 3s. And s is only 1 orbital. I'm going to need both of those. Okay, we're at 12, still not at 20. After 3s comes 3p. 1, 2, 3. 3p. And we'll draw our arrows. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Still not where we want. We can use all 6 spaces. And then one more, which is 4s. Okay. And we only needed 2 more. So there we go. Here's 4s2. The last arrow I drew is this one. So quantum numbers. First quantum number is our energy level, so 4. Then our sublevel, so S is a 0. Within S, there's only one orbital option, so that's a 0. And since it's spinning down, it's a -1/2. Now, if we're looking at valence electrons, so our highest energy level out of all of these energy levels is 4. Okay, and this is the only 4 there is. So there's 2 electrons in the 4th, so there's 2 valence electrons. Now let's do one more example. So iron. Iron, if we look at the periodic table, has 26 electrons. Okay. So we're going to start with our 1s, 2, our 2s2, and I'm going to speed through this because if you're looking at what's up above, we got to 20 getting to 4s, so I'm just going to get to that point again. And you're going to start hating me once I give you bigger things because you're going to draw so many arrows. Okay, so we're at 20. We still need 6 more. So let's look at what comes after 4s. 4s and then 3d. Okay. Now with d's, you draw 5 orbitals. And I told you we only need 6 because this is a 20. So 1, 2, 3, 4, 5, and then 6. Okay, so we'll write our 6 here, and this is the last one I drew. Okay, so this is the quantum numbers we're describing. So its energy level is 3. Its sublevel is D. So D is 2. Okay. Within the D, it's in the first spot. So if we look at our D, the the first spot gets a -2. Okay, and it's spinning down, so it's a -1/2. Okay, so now the last thing we need to do is number valence electrons. Now, valence electrons, we're looking at the highest energy level. So the highest energy level here is 4. Okay, even though this is the last thing we drew, 4 is our highest energy level. And there's only a 4s. There's no p here, so within our 4s, there's 2 electrons. So we have 2 valence electrons. Okay. Now it's up to you to do the rest of the problems on your own.